Today I'm going to show you how learning occurs. I'm just going to introduce what some of this stuff is on here first. Here we have an AMPA receptor, and I'm going to draw the binding site right here for you. And here is an NMDA receptor in blue, and here's a binding site. Inside an NMDA receptor, we have a magnesium ion that's actually blocking the channel, which we'll talk more about later. And then in here I have just glutamate ions. And this is a presynaptic cell and my postsynaptic cell. So let's get to it. So if a presynaptic cell is firing rapidly in a short amount of time, this causes an action potential and for glutamate ions to be released into this synapse. This synapse already has sodium ions, which I'm going to show for you in blue, as well as calcium ions. So when that glutamate is released, if that neurotransmitter, which is the primary excitatory neurotransmitter, if that binds to one of our AMPA receptors, I only have one drawn just to make it simple. If that binds there, it allows for an inflow of sodium into the postsynaptic cell. The connection is actually still weak in this. In order for this connection to become stronger, the inflow of sodium ions is actually causing a depolarization of that cell. The depolarization of the cell actually causes a dendritic spike that pops out this block right here of the magnesium ion. And now glutamate can actually bind to this site on the NMDA receptor. This causes an inflow of calcium now as well into this postsynaptic cell. Calcium flowing into the postsynaptic cell signals an enzymatic reaction, and the AMPA receptors move into this dendritic spike that occurred. So more AMPA receptors are coming to this spike site. This is strengthening the synapse and allowing a long-term potentiation to occur. The more sodium inflow that's caused by all of these AMPA receptor, all this sodium that's flowing into the cell causes more depolarization and a higher probability of the postsynaptic cell firing. So I hope that helped you, and I hope that made enough sense. Yeah, good luck.